So we all know Terraform is amazing for defining your infrastructure as code. But the second another person joins your team, a huge question pops up. How do you actually work together without, breaking everything? Let's get into it, because getting this wrong can be an absolute disaster, but getting it right? Well, that's the bedrock of professional DevOps.
Okay, picture this. You've got two engineers on your team. They're both sharp, both working on the same project. One's adding a new server, the other's tweaking a security group. They both type Terraform apply and hit enter from their laptops at pretty much the same time. So what happens? Best case, one person's hard work just gets completely wiped out by the others. Worst case, you get a corrupted state file and your entire production environment is now in some kind of scary, unknown limbo. Yeah, that's the nightmare scenario we have to solve.
And really, it comes down to two very different worlds, which you can see right here. On the left, you've got the local state approach. That's where every engineer has their own little terraform.tf state file on their laptop. It is, and I'm not exaggerating, a recipe for total chaos. But on the right, you have remote state. This gives you a single source of truth that actually allows for real teamwork and safety. For any team that wants to stay sane, the choice is pretty obvious, right?
So look, the most important thing to get is that everything we're about to talk about, it's all built on this one core idea. You must have a central source of truth for your infrastructure state. For any team using Terraform, this is completely non-negotiable.
And that central source of truth, it's managed by what Terraform calls a remote backend. It sounds fancy, but it's really just a shared remote place, usually a cloud storage bucket where that one single authoritative terraform.tf state file lives. Once you set this up, every time anyone runs a plan or an apply, they're all looking at the exact same blueprint. Everyone is working from the same up-to-the-second reality.
And the great news is, you've got some fantastic options. You could go with Terraform Cloud, which is awesome because it's a managed solution that handles a lot of the tricky details for you. Or you can roll up your sleeves and use the cloud storage you're probably already using, like AWS S3, Azure Storage, or Google Cloud Storage. They all get you to the same place, one state file to rule them all.
And you know what? Setting it up is surprisingly easy. You just pop a backend block right into your Terraform code. In this example, we're just telling Terraform, hey, use this S3 bucket and put the state file right here. But pay close attention to that very last line, the one that says DynamoDB_table. That's a little sneak peek of where we're going next, and trust me, it is critically important for keeping things safe.
Okay, so we've laid the foundation. We've got our single source of truth with a remote backend. That's step one, and it's a huge one. But now it's time to build on top of that. Let's add some essential guardrails to take our workflow from just functional to truly controlled and safe. We can break these guardrails down into three simple steps. First, we have to lock the state whenever someone is making a change. Second, we need to isolate our different environments from each other. And third, we absolutely have to secure who can access the state file itself. So remember, lock it, isolate it, secure it.
Let's start with locking. State locking directly solves that two engineers at the same time problem we talked about. Think of it like checking a book out of the library. When one person starts a Terraform apply, Terraform locks the state file. If anyone else tries to run an apply while it's locked, they'll just get a polite message telling them to wait their turn. This completely eliminates those dangerous race conditions and prevents your state file from ever getting corrupted. Seriously, this isn't optional. It's an absolute must-have.
Remember that DynamoDB table line from the code a minute ago? Well, this is why it's there. S3 itself doesn't have a native locking feature. So Terraform gets clever. It uses a simple entry in a DynamoDB table to act like a little check-in, check-out sheet. Other backends, like Azure, have a locking feature built right in. And if you're using Terraform Cloud, the best news of all, it's all handled for you, automatically. No extra setup needed.
Next up, isolate it. The last thing you ever want is for a change you're testing in a dev environment to accidentally get applied to prod. That's a resume-generating event, right? Well, Terraform workspaces are the perfect solution. They let you use the exact same code base, but they maintain totally separate, independent state files for each of your environments. So your dev, QA, and prod environments are in their own perfect, isolated sandboxes. And finally, we have to secure it. Your Terraform state file can be a treasure trove of sensitive data. We're talking database passwords, API keys, the whole shebang. You have to treat that file like any other production secret. We do that using the standard security tools of your cloud, like IAM in AWS or RBAC in Azure, to act as the bouncers at the door, making sure only the right people and the right automated systems are allowed to touch it.
All right. At this point, we've got a secure, collaborative foundation. We have a remote backend, we've got locking, and we've got isolation. That's good, but if you want to go from good to great, the way the real pros do it, you need to bring in automation.
First up, a critical safety net, state versioning. On most backends, like S3, it's just the feature you can turn on with a single click. What it does is keep a complete history of every single change ever made to your state file. So if the worst happens, if something goes horribly wrong and your state gets scrambled, this is your time machine. You can just roll back to a previous known good version and breathe a huge sigh of relief. It's an absolute lifesaver.
Now for what might be the single most important rule for any mature team using Terraform. The gold standard is this. Nobody, and I mean nobody, runs Terraform Apply from their laptop. Period. All changes must go through an automated system.
So why are we so dogmatic about this? Because running Terraform through a CI/CD pipeline, something like GitHub Actions or a GitLab CI, just solves a ton of problems at once. It guarantees every single run happens in the exact same clean environment. No more, well, it worked on my machine headaches. It creates a perfect paper trail, an audit log of who changed what, when, and why. And maybe most importantly, it lets you enforce policies like mandatory code reviews and approvals before anything gets changed in production.
Okay, we've covered a ton of ground here, all the way from the basics of a remote backend to the gold standard of full CI/CD automation. So let's boil all of this down into one clear, concise takeaway that you can actually use.
Imagine you're in a job interview. They lean forward and ask, so, how do you manage Terraform state when you're working on a team? This is your moment. This is your chance to show them you don't just know the commands. You understand the principles behind professional infrastructure management.
And here's that perfect interview-ready answer. You'd say, I manage Terraform state using a remote backend, like S3 with state locking. Each environment, like dev and prod, has its own isolated state file. Access is controlled via IAM, versioning is enabled for disaster recovery, and all changes are executed through a CI/CD pipeline to ensure consistency and security. Bam! With that one sentence, you've just proven you get it. You've shown that you think about collaboration, security, disaster recovery, and automation. You've shown them you think like a pro.
So with all these practices in place, your Terraform state is no longer a source of anxiety and chaos. It's a stable, secure, and reliable foundation you can build on. And that's when the real fun begins. The question is no longer, is our infrastructure safe? The real question becomes, with that solid base established, what amazing things are you going to build and automate next?